Okay, on problem number 1, they see we got a curve y equals 5 minus 2x plus x squared and a line y equals 2x plus k, and k is a constant. So they want us to show that the x coordinates of the points of intersection of the curve and the line will be given by the equation x squared minus 4x plus 5 minus k equals 0. So basically what we've got to do is, these both already do y equals. Since they're doing the intersection, we just got to make these two rules equal to each other and then get them equal to 0. And so it looks like what they want us to look like. So I want you to pause this and then do that and then start back up again when you're ready. Okay, fantastic. So when we do this, this is what I got. I'm going to end up just subtracting everything on the other side, and I get exactly what they say it should get. And the way you do this kind of thing is, then after you've worked on and shown all the steps, then you write proven just so that you're done. All right, now in part B, they say for one value of k, the line intersects the curve at two distinct points, A and B. The coordinates for one, A, is negative 2, 13. Find the coordinates of B. Now, in that situation, we know one of the coordinates. It's negative 2, 13. That's an x and a y. So if we go to this equation where they've been put together, our two curves, our curve and our line, and then we replace the x with this, what we're going to find is we're going to find what k is when x equals negative 2. So when we plug this in, we're going to find out that the value of k when x equals negative 2. So pause this, replace all those x's with a negative 2, and then simplify it and get k by itself, and then start back up again when you know what k equals. All right, fantastic. This is what I got. I put a negative 2. Make sure you put it inside parentheses. When you get that squared, what you're going to find out is that k is equal to 17. 4 plus 8 plus 5 minus k. I'm going to get k is equal to 17. So now that we know what k is equal to in this situation where the one point is equal to negative 2, 13, what we can do is we can take that k and put it back into that equation, and then we should be able to find the other x. So pause this, stick that 17 in that equation, and then solve for x. All right, fantastic. So this is what I got. When I put that in there, I'm going to end up with x squared minus 4x minus 12, and that factors, and I get two x's. One's a 6 and one's a negative 2. Well, I expected to get a negative 2. All I got to do now is find out what happens when I put in a negative 2 and a negative 6. I'm assuming that's going to be a 13, and it is. And then when I put in the 6, I get a 29. So the point that I didn't know is 629. All right, now part C. For the case where the line is tangent to the curve at point C, find the value of k, and then find the coordinates of C. So now we've got a whole different situation. Now the k is going to be different, because in this situation, the line and the curve are tangent. And when we're talking about this, we're looking at the discriminant, and the discriminant is going to equal 0 when it's tangent. So what I want you to do is take a look at that quadratic equation that we made, and then use the discriminant, make it equal to 0, and then solve for k. And then tell me what k is, and then start back up again. Fantastic. So here's what I got. I'm going to go through and put all this in, and then when I simplify it, I'm going to find out that k is equal to 1. Well, now that I know that k is equal to 1 when these curve and the line are tangent, I can go ahead and plug in the k for the linear equation where the 1 was, and where the quadratic, and I could go ahead and solve those, or I could use the equation I've already built that has the two intersections, and then just make sure I replace the k with a 1. So go ahead and pause this and then solve for x, and then start back up again. All right, so we get x squared minus 4x plus 4. That's going to give us x minus 2 times x minus 2. X is going to equal 2. And when I plug the 2 back in the linear equation, I find out that the y is going to be a 5. So when the line and the curve are tangent and k equals 1, well, then the point where they're tangent, point C, is going to be 2, 5. All right, hope that helps. Thanks for watching.